All right, so let's take a look at some answers here to the 4-1 problems. There weren't very many problems to do because there's not much going on there. What is the composition of rigid motions that maps this figure onto that figure? I guess the funny thing is there's a lot of different ways that you could do this and make it work, but it seems like we would need to reflect this way somehow. Um, and then slide it so that it matches. And it doesn't really matter how we reflect this. Like we could try and get fancy and reflect it across the line y equals 5. Because then if we did that, we would only have to slide it straight over. So that would be like a translation of 1, 2, 3, 4, 5, 6. So that would be a translation of 6, 0. And then remember in our super weird notation that that comes second, even though, or no. Well, I guess actually it doesn't matter which way we do it. Anyway, and then you could also reflect this across the line y equals 5, and then that would work. But if you wanted to, you could flip the whole thing over the um, x-axis, and then it would be way down here, which is a little bit weird, but we can do a translation that slides it both left and up. So from here, we could go, did I say left? I meant right. We could go 6 to the right, and then, I don't know where this would be. If this was at 9 to start with, then it would end up down here at negative 9. So it looks like I would have to move it up 10 to get it to match. Can you understand any of this? So that would be a reflection over the x-axis followed by a translation of 6 to the right and up 10. But there's like an infinite number of ways that you could do it. So some sort of a reflection and then a translation. Which two triangles are congruent? So it looks for sure like these two are. And are these two triangles congruent? Let's see, this has a length of 1, 2, 3, 4, and then 1. 1, and then 1, 2, 3, 4. This is 2 and 2. This is 2 and 2. And then this one is 1 and 2. Yeah, okay. So these two are also congruent. So that's fun. Are figure A and figure B congruent? Yes. If triangle JKL is congruent to RST, give the coordinates of possible vertices of triangle RST. Yeah, so again, you could pretty much do anything you want. It'd be super easy to just slide all these points down 1 and then get a new triangle, but you could do something fancier than that if you wanted. Okay, given square JKLM and the translation blah and blah, what is the area of RSTU? Okay, well, tricked you. Since these are both rigid transformations, they don't change the size of the shape, so it doesn't matter where it ends up, it's going to always just have the same size. And since it's a square, that means that both sides are 12 centimeters, and so the area would be 12 squared centimeters, or 144 centimeters squared. Same thing here. If this is reflected over this line, since that's a rigid transformation, the perimeters are going to be the same. Okay? Well, that was super easy. That was just a little introduction to congruence, I guess.